2021. Bhatkar sir worked with different MNCs like Cognizant Technology Solutions, Capgemini, Infosys, Tata Consultancy Services, and many more. Sir, having interest in investment banking, wealth management, capital market, machine learning, blockchain, and quantum computing. Aim of sir is to perform applied research, monetize the outcome, and solve the financial industry. Likewise, we have Emerton's great person today for this session, and also recently sir given a session on quantum computing in the KK Engineering College and Research Center. So I welcome you all and request to start your session.
Welcome, Bhatkar sir. On behalf of MET Institute of Engineering, Computer Engineering Department, I welcome you for this particular faculty development program on quantum computing. Please, sir.
Thank you. Thank you, ma'am, for introduction. And
you,
sorry for the hiccups. It happens. It's technology. Thank you, More, sir. Good morning. And
good morning, sir. Good morning.
Dr. Kharat. I think before I share my presentation, certain things, I hope I am audible, first of all. Second thing
yes,
is,
audible.
You can put your questions, queries in the Q&A or your chat windows. Second thing is, you have been listening to this fascinating area called quantum computing and getting introduced to it. A lot of eminent personalities spoke before me, whether it is Professor Paul or Dr. Kharat or for that matter, Dr. Bhavna, etc. And you have fairly an idea about what it is, why there is so much fuss about this particular phenomenon called quantum and the computing based on the quantum physics or quantum mechanics called quantum computing. And that is important. First of all, there is something called research, R&D, and then how do I apply that research? And today's session will be little bit different because theory is enough. Typically what happens in the business world is, so what is the biggest question. Something happens, then so what? And what is in it for me? The business runs on a very simple principle. What is in it for me? And so what? So yes, lot of potential, lot of promising technologies, lot of claims, I would say, of quantum computing. But then what? How can it help me? That is what happens. No matter which technology you take, cloud computing 10 years ago or social media integration, data analytics, machine learning, AI. Machine learning, AI 5 years ago, people were very skeptical whether it is going to be useful or whether it is not going to be useful, right? But industry, there is a pattern in adoption of any new technology in industry. And first question, as I mentioned, is always, so what? Yes, you are great, you have a lot of potential, but then what? What is in it for me? How can it benefit me? And today's session will have flavor of this. Again, a practical business wise available quantum computer is not there. A lot of promises are there, but there are few headways that we have made in this technology, and people have started reaping the benefits of those early initiatives or early results. So we'll touch upon most of those aspects. It will be a fairly an interactive session, and you can interrupt me if I'm going too fast. And at the same time, also, please note that it's end of the day, it is going to be a business or applied quantum computing, as you would say. So some of your questions may actually lead into a different area or use case of utilizing the quantum computing. So less of a mathematics, I promise very less theory. You need to know few principles only, and a lot of discussion on how can certain things, how can a technology like quantum computing be applied in various domains, and how can it help us. You have seen that in yesterday's Dr. Panigray's lecture, I believe, the initiation on the domain wise, how you can use it. So we'll go a little bit more detail and then see what is happening around the world. So thanks, first of all, thanks for inviting me, giving me this opportunity. I do love sharing my experiences, limited experiences. As I mentioned, I'm not an expert. You have been fortunate to listen to quantum computing expert, but I am essentially a programmer or a engineer who always thinks in terms of how can I use the new technology or disruption in the technology for betterment of either society or for my business. So it's very plain and simple. Okay, I'll present my screen. Hopefully this should. Full screen, and then I want to reduce this change layout. That should be only the spotlight one. Sorry, I typically would not like this. It should be in the classroom, but we are in a different time right now. What is happening? It's going into some sort of, just give me a, I hope now it is. Are you guys able to see my screen?
Yes, sir. Screen is visible.
Yes, sir. Screen is visible.
And it is not going in infinite loop, right?
Oh, no.
Okay. So
Yes, it is playing now. You can hide it.
okay. So as you can see in industry, there are certain rules, especially if your organization is a listed and public organization.
Sir, can you go on first screen, first slide? Can you go on first slide? Yes, yes. Just check. I need to click that. Yes, sir. Proceed.
So one disclaimer that I want to put it here: whatever we discuss in next hour and a half is are out of interest, out of my hobby, has nothing to do with the job that I do or my previous or past employees. And like in a medical advice or a financial advice, do not make any decision. We don't own any decision that you will make, except for the academic and educational research, whatever technology and the concept that we present. So if there is a, based on certain things, you decide to take certain decision, we are not responsible. This is a disclaimer. We have to, being in a professional financial institution, we have to raise it. But essence is basically learn this from a R&D and educational purpose, academic purpose, apply it. If it can be beneficial for the larger society, well and good. If it can be beneficial to your organization, well and good. But the main thing is we don't own that decision. If there is a loss or profit based because of certain decision that you will make on this, we have nothing to do with it, because that's what the disclaimer is. Second thing is, there are a lot of trademarks, a lot of copyright, lot of sources. Wherever possible and wherever there was a source behind that data, I have clearly acknowledged it, because the last thing we want is copying somebody's data and somebody's hard work, right? And we have cited the further readings and references as we go along. You will find that interesting list of books. I won't take too much time. This is essentially what Madam has given my introduction about. But the main important part is I look for opportunities where I can read certain things, apply that research, monetize that research. There has to be a monetary outcome of whatever you are doing. Otherwise, it becomes an academic exercise which is never ending. And specifically because I have been throughout my career working on the financial industry, I typically take the problem statements or the use cases from financial industry and try to solve them. How to adopt certain new concept, how can we utilize it? And I'm happy to, if somebody has inclination, want to explore certain things further, there are certain use cases, not only in quantum computing, but the deep learning and machine learning as well, which we can discuss one-on-one and separately, not in this call, but let me know if you are interested to work with and kind of do some kind of applied research along with me. So I already presented at a national level on the quantum computing. Quantum computing, more of a hobby. It was after kind of 20-25 years in doing the bits 0 and 1s, I got involved into it, and thereafter did a 1-year course on qubit by qubit. By 2021, I was undergoing a training program, 2-semester training program by essentially taught by MIT and Oxford professors, and sponsored by companies like IBM and Google. So that's what you will see here. Certificate in quantum computing. Qubit by Qubit is the name of the organization that distributes the certificate, but essentially run by the professors in MIT and Oxford doing R&D in the quantum computing. And the best aspect of that program was the way they have treated the mathematics behind it, right? So because what happens is, if somebody dwells deeper into quantum mechanics, and then they will be all the time talking about certain equations and the mathematics, but how do I apply those concepts and how do I take it forward? Because research, fundamental research is very important, but at the same time you need to understand which are the concepts that can be practically implemented, taken advantage of, and which are the long-term exploratory goals, right? That is how any research will happen as well. Then I did a course last year in machine learning from IIT Kharagpur. This was purely mathematical treatment to the machine learning, and that is when I wanted to marry two things. One is the knowledge about quantum computing and the machine learning AI together to come up with something very essential. And then I found out there is a free course. Anyone can actually within 80-90 hours do that. It is on Simply Learn. You can install the app or you can directly log into using your Google ID. But I would recommend that the sequence is, you understand the basics on machine learning, the mathematics behind it, and then go for this course, which is a practical machine learning course, free course from the Simply Learn. Even if you don't want to go through the mathematics of machine learning and IIT Kharagpur, I would really recommend that whatever the project and labs that are given in machine learning course by Simply Learn, just try to do those locally. It will be a great help. Your concept, because people are now talking about quantum AI, and that is where this is heading into. Okay, so as Madam said, work for all the big IT companies. I don't want to go through the list as well, but as I mentioned, the job may be different. This is my passion. This is my hobby, quantum computing, right? So you can look at this slide into two different perspectives. There was a skepticism. There was a lot of people were doubtful what will happen to AI. Can it be practical? 25 years ago, when I joined TCS, Tata Consultancy, there was a group called Natural Language Processing and AI. Nobody used to join that group. We used to work on backpropagation algorithm at that time, which is today mainstream technology. But we used to work on network optimization algorithm and problems at that time. And one of a great scientist on Dr. Vivek Balram used to lead that group. So you can see that in 25 years that there were no people saying that it's not a customer project or client project. Suddenly people started adopting it. So same thing happened with AI, same thing happened with social media, analytics, and cloud computing. Not only in parts, this is a mainstay of technology. People are talking about cloud native application development. Nobody wants to go the traditional way now, because the business runs on a very simple principle. Unless there is a cost benefit analysis, unless there is an ROI, return on investment, nobody works in a business on a new technology. So people have seen that having an intelligent automation, AI based automation, they can save the dollars, they can save the money, and they can actually use that money for the further enhancing their business rather than the IT, right? So there is a shift that has happened in last, especially in last 4 or 5 years. And that shift is, earlier it was business that used to drive. IT was a back office of every business, saying that okay, we are like a support organization within an organization. Today it is different. Today, as we will see, the IT is driving the business. The disruptions are coming from IT. A lot of things which were not possible 20 years ago are suddenly possible. And what is happening is, because of that, IT is at the forefront of the business. And almost every, whether you take a bank or an insurance company, or you take a retail, something like Amazon, something like Alibaba, which are the logistic companies or the retail companies, they have turned out and become actually a much bigger and better organization as a IT organization, more a technology organization rather than the business organization. So remember this shift. The IT is a driver now for the disruption and doing the business differently. So please remember that. That's what I wanted to show, that the disruptions, especially technology disruption, are good for the business, because then it brings in a different perspective. Blockchain RPA is now mainstream technology. Blockchain adopted partly. Quantum, what was 3 or 4 years ago, AI, machine learning, and cloud, quantum computing is going to be that mainstream technology in 3 to 5 years. We are not talking about 10 years from now. We're talking about maximum 4 to 5 years. People, the investment that has been done, a lot of companies that are there will start reaping the benefits, or ROI will start kicking in almost every business that has invested heavily in quantum computing. It's the interesting. Few years ago, when I was watching the Big Bang Theory series, I suddenly stepped up upon some of the wave functions and quantum mechanics concept, and I think that you can say that was the trigger, inspired by Dr. Sheldon Cooper in the TV serial, and engineer Horowitz. Howard Wolowitz. So Wolowitz is something which I can relate, because I am essentially an engineer, and then the scientist like you guys can relate with Sheldon Cooper. So that's a tussle between PhD doctorate holder Professor Dr. Sheldon Cooper and the engineer, somebody like who has never been PhD but just a master's from Howard Wolowitz. So it's a good series. If you understand the concept of quantum computing and then watch the entire episodes again and again, you will really enjoy it. There is one important area, quantum AI, and we'll touch upon that. It's a very niche area, very specialized area that is happening today. There are few things I would like to put a after disclaimer. It's around roughly 90 minutes of session. I'll keep on talking. But it's as you can understand, it's not possible to cover everything. So there may be few things which I will just touch upon. Few slides I will go deeper into, because that's what the purpose is. Basically, my aim is that after this session, you should be able to take one particular aspect, one particular thought process with you, and then start thinking over it. How can it be beneficial to me, or society, or the humanity at a large, right? That is how you should look at it. Some prerequisite terminology, as I mentioned, not too much maths will be provided, will be sufficient also. Don't get into the bogged down by the details. Business strategy, what should you look into, and how can I move from the quantum computing in research into quantum computing as applied quantum computing. So we are making that shift as we go along. As I mentioned, people who have invested 4 or 5 years ago in a lot of startups in quantum computing, they have started asking the question, where is my money? Where is return on investment, right? We'll go through the case studies. Some very interesting, very latest case studies, and I'll also have a demo on the optimization, just to show you how you can actually further dwell into this area. What are your expectations? I am giving you, I also need to take a break of talking. 30 seconds for you. Just in one liner, tell me, what are your expectations from this session? Are they different from what we are going to discuss? Is it too high level? Is it something which you relate or don't relate? But essentially, we'll give a spin off to the concepts of quantum computing from the business perspective. Good.
Sir, participants are posting in chat box. If you see,
I'm just sharing that. 30 seconds is what I gave you. Because if you think too much, then there is a problem. So good. So basically, I can relate it. Most of the messages are that we want you guys are interested to know what the practical use cases are, and I'll definitely touch upon that aspect, because that is what the session is all about. Shamik, Iqbal, anything there? You raise the hand. Any specific question you have? Okay, let's go. Again, not all the questions will have an answer. It's not possible. Nobody can claim. You can see on the right hand side, from Schrodinger to Albert Einstein to Professor Feynman or Dr. Wheeler, right? Especially Albert Einstein never understood what is quantum and why it is certain things are behaving in such a dual way, right? And that is when he made that statement. If this is correct, then there is the end of physics. I don't understand the science or physics. And it happened. The entanglement or a spooky phenomenon at a distance has happened. Two things were miles apart were actually behaving in some tandem, and that is when he said that this is beyond my understanding. So if these greats don't understand the quantum mechanics and quantum physics and don't claim to be understanding it, neither you should be. You take out whatever is important and relevant and then expand on those concepts. That's what. Most importantly, Even if you don't understand certain things in the first place, don't panic. It will be all right. And sometimes it's better to take a little bit high level view rather than getting deeper into one particular aspect. As you can see, you typically have various career paths. What can you do in quantum computing today, right? You can become if you think that I want answer to all the questions unanswered, preferably you will be physicist or doing some foundation R&D work in quantum theory. Example being experimental particle physicist and director of CERN Switzerland, Fabiola Gianotti, right? You can Google her name. You will find the wonderful work and research she is doing on a fundamental physics. You may decide, okay, I'm okay with living with some certain uncertainty, not want to understand everything in detail and the reason for, but I want to work on the applications of some of the concept. You can be physicist, you can be engineer, and you develop uses or use cases for the quantum theory. Yeah, a great example is Clarice Alo, UCLA quantum engineer and expert in nanosensors. She has developed nanosensors for the medical use using quantum computing as a technology. You may be somebody like me. I just want to run certain algorithm, take their advantage, become a computer engineer who knows quantum concept. That is Peter Shor, whose algorithm by now everybody is afraid of, right? That it can potentially break the RSA encryption. So you have all these possibility. You can choose to become one of that. One is not essentially bigger or greater role. Anything is possible. A pure physicist, theoretical physicist, engineer / physicist, or a computer scientist or computer engineer. Go through some of the basic concepts of trigonometry, linear combinations, vector, matrices, complex number, eigenvector, eigenvalues, probability, and Dirac's notation. That is a bracket representation of quantum state. You can go through Khan Academy. They have a very good material, and then I will be sharing this presentation as well. So at MIT Open Courseware, you will find a great treatment on this topic. The way some of the US university teach you the applied mathematics or engineering mathematics is way different than what we learn in India. Just for the fun part of it, even if you know this concept, just go to the MIT's Open Courseware and try to find out how they are teaching trigonometry or linear combinations or vectors, and how it helps to understand the concept, because they take one concept, go in depth into it, and they always end it with the application. You will need to know little bit of Python programming, if not at least SciPy and NumPy, some of the learn also, and few matplotlibs and all other libraries. So most of these libraries will be required. Basic of the domain, whatever you choose to dwell into, and either nowadays there is always a cloud version of everything. So programming environments, typically Visual Studios or your PyCharm or PyTorch or Anaconda, and integrated with Qiskit or Cirq, which we will discuss. Concepts of quantum mechanics, which are very relevant. Superposition, by now everybody knows about it, so I'm not going to even spend a second there. Decoherence is basically unwanted interference, or coherence is the important phenomenon, and entanglement, which is a spooky action at a distance, where between pairs there is some relationship and they behave in a certain tandem way. When you change one qubit, for example, the other also gets impacted, although they are not related and they are distance apart, right? de Broglie's wavelength duality, particle wave duality theorem, lambda equal to h upon p, that would be useful understanding. And then of course Schrodinger's equation in hardware design and controls. But that is only if you are programming at or controlling at a pulse level. You need to know all these details, but good to have prerequisite before you get deeper into it. I don't want to get into the details of this, but this is required because whenever we are talking about uh, the scale of improvement, or why certain things are possible and why not, it is important, right? So typically, just a quick revision. It is a big O notation or order of notation. So constant is order of 1, logarithmic is order log n, linear is n log n is n into log n, quadratic is n square, cubic is n raised to the power 3. The reason they are in green is they are all polynomial or tractable. Example, minimum spanning tree, ordered, unordered list search or database search, for example. They will take this much time or complexity or time to execute, right? Then there are exponential, right? K raised to the power n or order of 2 raised to the power n. N factorial and super exponential, that is n raised to the power n. Some of the example, tower of Hanoi problem, you might have heard about this in computer science. Any permutation like factoring a very, very large prime number, for example, these are the problems that become intractable or exponential complexity. The similar notation is polynomial time deterministic algorithm, which we call P. NP, again non-deterministic, guesswork. We do some approximation and then we say, okay, let me solve with this approximation in a polynomial time rather than solving the problem exponentially, because today no computer can actually solve these problems in a reasonable time, right? And then verify that, okay, you have solved it. So that is NP, non-deterministic. Some guesswork, some approximation, convert it into polynomial and execute it on our classical computer. NP hard problem. All problems are NP plus reduced to polynomial. And NP complete is a problem which is both NP hard as well as NP. So how does this matter? As the value of n increases, the order or the number of digits, number of time or the years it will take to execute certain things changes. It's very, very important calculation, right? So just to give you the idea, the number of protons in the known universe is 79 digit, and we are talking about 1 million digit or 1 billion or 302 digit number if it is 2 raised to the power n or n factorial or n into n. So basic is if the order is exponential, after some time for a large n, it becomes an intractable problem for the classical computers. Okay, whether quantum computers will be able to solve it or not, that is something which we will see soon. Okay, but this is what the basis for so much interest in quantum computing is. I'll highly recommend 2 books for you. Both are available as a PDF online version as well. There is a book called Algorithmics, The Spirit of Computing. Every computer science or computer engineer or IT engineer should have this book. This will give you all this, whatever I just explained in 5 minutes. Donald Knuth is known as Art of Programming. There is a series, especially volume 4 is very much relevant for the quantum computing because it all combinatorial algorithms there. I will move to the next part. I don't think I need to spend too much time. It is basically binary is bit 0 and 1. Qubit or quantum bit will be 0, 1 or both at the same time. That is a superposition. Entanglement is if I change 1, the second qubit also changes. No matter what is the distance, they are perfectly entangled. And the interference is basically the waves in superposition. They can either amplify each other or they can cancel each other. Yeah, if you put 2 stones at the same time at a distance in a still lake water, you will notice this phenomenon of interference, right? Either the waves will increase or waves will the amplify or they will decrease, right? So why it is important? Because these three concepts, quantum qubits, superpositioning, entanglement, and interference, they drive the entire quantum computing theory and the science behind it, right? So what does the future look like? Uh, uh, there is a fundamental shift, right? It's no longer 0 and 1. What we all learn, it is no longer binary. World is not binary. World is not black and white. It is some shades of gray, and that is what is important to understand. That it is not just a technology change. It is not simply another paradigm or another programming language. It is a complete thought process has to change if you want to be reap the benefits of quantum computing. So if you look 30 years before, Pascal and Fortran, which are the functional languages, were primarily driving the change. Then came the object-oriented programming. It was a paradigm shift because a lot of things has to be unlearned more than learning totally new. And sometimes it is easy. That's why they say that it is actually easy to teach quantum mechanics and quantum computing to a 10th or 12th student rather than an engineer who has gone through the classical binaries and the Boolean algebra. So it's a fundamental shift. Appreciate that. Be open for learning new things. Superposition, entanglement, they allow the computer to solve the intractable problem which we have seen using, because it's closely related to the nature. That is how the nature is. That is how the problems are. And not every problem can be efficiently and cost effectively solved by the quantum computers. So they are not going to replace the classical computer. What we the laptops and the servers that you have invested in will remain valuable. Most importantly, it will be a hybrid quantum classical architecture. So both classical, the Boolean algebra or the bits and binary bits as well as qubits have positives and negatives, their strengths as well, right? So some recursive problems, some approximation, and some sampling and simulation, those deterministic problem can be very well solved on a classic computer in a cost effective way. They will coexist. And then what you can do, actually, you take a portion of the use case, run it mostly on the classic computer, only for the part that requires a natural representation where it is not 0 or 1, but the shades of between 0 and 1 also, or both at the same time, and then solve that problem, get the result back, and then again present that result. So it will be a hybrid quantum classical architectures that will drive the next decade. They will coexist, as I mentioned. An example would be the GPUs have come, graphical rendering for graphics, post graphics. Every computer today has a GPU. That didn't replace CPU. So CPU will continue. Some of the calculations where classic computer is master at will continue to be run there. So don't expect that there will be a massive program has to change. It will be another Y2K and COBOL programs and needs to change. That kind of wave is not going to come. There will be certain use cases that are the certain problems that we today think that it is not possible to solve because of the limitation of classical computing. Those will be solved on the your quantum computers, and the results again will be presented by the classical computing, because there are certain restrictions. You have in earlier sessions you have seen that it's a costly affair, first of all. Second thing is it's maintaining the state of superposition, the time, the moment you measure the values, it collapses back. So all those coherence time, etc., those are all important factor, and it's a costly investment. Not everybody can afford a quantum computer, at least not now. So it's not going to, they are going to coexist, not replacing each other. Interesting IDC survey. There are 8% people says that they are already dealing with what is the quantum computing and what will be impact on my business. 35% are keeping a eye on it, keeping a watch on it. 57% don't even, they think that it is not relevant to us. In future, would you be able to take your industries and how would you rank? Then 63% is positive, yes, this will have an impact on my business, and 37% says no. This is exactly in a similar proportion if you would take the 10 years ago survey on the cloud computing, you will find exactly same distribution. 60-40 was at that time people in favor of cloud versus cloud is of not going to impact me. Exactly same. So uh, given the early nature of the and the headway we have in quantum computing, this is a great survey. This was recently done, and this means that there are 65% people who are positive about the technology. Whether it will really help them or not is a different story. Inside IBM Quantum Lab, it's real. Just wanted to show that it's not something which when you send something for the execution on a quantum computer, then it is actually executing on the quantum computer. One of the quantum computers of 20 odd installation that IBM has today, right? Look at it, where we started, 5 qubit chip. This is the architecture. This is how it was burned on the your PCB or circuit board, and this is the room. This is a super cool. This is a absolute zero rooms or Kelvin 0 degree. That is minus 273 degree. Why there is so much excitement? Okay. Programmable quantum device that can solve a problem which no classical computer can solve. There is a first movers advantage. That is what the quantum supremacy means. China claimed it, they have achieved it. Microsoft is behind it. Google has already proved that they have achieved the quantum supremacy. The problem that cannot be solved in a reasonable time on classical computer has been solved on a quantum computer. That is all that quantum supremacy means. Lot of interest, lot of people investing in, and recent development, whether it is BMW, whether it is Microsoft quantum computing, which is basically Azure quantum now, and Google, which is again Circ or Tensorflow quantum computing. The interesting part is a very recent news. Somewhere in 25th or 26th of November, US debarred and banned around 13 companies, China-based companies. And the reason for that, we will come in next few slides. The reason for that was most of these companies are working on quantum computing technology, and that was the US suspects that they are using this technology for a military gains or military supremacy. That's an important. Again, most of our calculation or discussion today would be 2 raised to the power something, 2 raised to the power n possibilities, for example, in quantum computing. There is the Rigetti computing has again transformed 13 days ago, last month in December. They have come up with and presented a paper saying that it is not only 0 or 1 in quantum processes that Rigetti has. They have introduced a third state also. So that's an hybrid state. So everything what we are talking about, like 2 raised to the power n possibilities in or possible state, has suddenly become 3 raised to the power n possible state. So it is not like every additional of bits will increase the processing power certain. It is an exponential increase, and now you can imagine that it is the base of that exponential increase is 3, not 2. So this is an interesting article. They are calling it Q-treats, basically 3 possible state of every qubit. The third state is hybrid state. What is the market size? Again, nobody is able to predict what is the market size, which industry will drive the quantum phenomena. But you can see here various industry and how they will stack up, right? Essentially agriculture, interestingly, and life sciences, and the third one is your automotive, logistic, manufacturing. Those are the things which will drive it. This is essentially we are talking about $10 billion in 2030, but then it varies because specific use case are still uncertain, and market forecast, it's very difficult what will happen in next 4 years or 5 years, especially in a fast changing world like quantum computing, right? But the good estimate is McKinsey's estimate, which says that the market value or market cap will reach around 1 trillion by 2035. Again, that can change. It's from 29 billion to your 10 billion here. So all said and done, the essence of this slide is basically look at the interest that is going from 2020 nothing to 21, 22, and then this is important. How fast you can go from 22 to 23, or whether it would be, it again depends, lot of unknowns, but this is what is happening. Why it is important? Because it is a tech dominance. Why US and China are fighting for that pole position, the first position, right, in the quantum computing history? Because first country that produce a effective working quantum computer will have a key advantage in economics. We will see how when we deal with finance use cases, in defense, and in cyber security. US, China, and Europe all are in the competition. So Europe also, they are spending money like anything just to make get themselves ready for this quantum computing phenomena. China already claimed that they have developed a quantum equipment, and it has a potential for military application. Again, coming from the China itself, very rare. Scientists in Tsinghua University developed a quantum radar that can actually leave all the stealth technology or aircraft, stealth aircraft, that will be useless, because by generating a small electromagnetic storm, this particular quantum radar can actually spot stealth aircraft as well. And that is last year or this year's achievement. In 2017 itself, they have Chinese Academic of Sciences, which is actually funded by Alibaba, also developed a quantum submarine detector. So they can actually spot the submarine below the sea level from hundreds of kilometers away. Now you will understand why the 12 companies has been banned. We are not far behind also. Indian Army on 29th of December declared that they have set up a new quantum computing lab and Artificial Intelligence Center of Excellence at Military College of Telecommunication at Mahu near Indore. And Union Budget 2021 has proposed 8,000 crore on a national mission for quantum technologies and application, NMQTA. So we are also not behind, but we are probably not at the same scale that US, China, and Europe are pumping into this technology. But we have certain advantages. First is quantum physics and quantum mechanics is our strong forte. So is China's, because you'll see the number of PhDs in quantum physics and quantum mechanics in China are highest in the world. So that advantage of understanding quantum physics, quantum mechanics, quantum phenomena, plus the advantage of IT ready workforce or the programmers. So those are our advantages as a nation, and we should I think dedicatedly focus to counter some of our rivals as well as neighbors in this space. We in 2018 Department of Science and Technology, they have unveiled a program called Quantum Enabled Quest which is Hyderabad-based government of India's initiative for quantum computing, and they started with a seed capital of 80. But again, as you know that there are the way research works in India versus the other places is little bit different. We need to actually, as a nation, need to look into couple of use cases that China has already achieved and prepare ourselves for, right? Because the first company, first nation who can break into the our traditional cryptography will have a massive advantage, and everybody in the world will be vulnerable. So it's better that we are also post quantum cryptography, for example, can be certain things which we as a nation we should start taking a control of. Any technology, take any technology, whether it is cloud computing, whether it is AI and ML, or whether it is any new product or technology, the business world is very rational. They don't go by the emotion. They will not invest so much money, and you can see the money that is being pumped into quantum computing worldwide. Quantum computing startups, how many startups has increased in last 2-3 years, and what kind of money they are pumping into this. So there has to be some potential. Whether that is realized or not is a different matter, but because there is a potential, people see a business in it, people see the first movers advantage in it. The investors are putting a lot of money into quantum computing startups. Very quickly, the parallel between what does it mean by quantum computing stack? Typically everywhere what it starts is your layers of abstraction, transistors, then the machine language, machine code, assembly, programming, algorithm, application. Same thing applies here as well. But we are talking about a realistic setup where quantum computers along with classical computer will coexist. So you will need a quantum software or simulation of those. Classical software will still play a role. Quantum program compilers, because you need something to translate that into quantum understandable into quantum state. Classical, all the controls, even in the quantum computers, even in the IBM labs, research lab where the quantum computers are stored, the controls are still done by the traditional or classical hardware that we have, and then obviously quantum hardware. So these are the stacks that will has to be there. What happened in 1969, where 4-phase classic processor was there, till today Intel i10, i11 and whatnot, right? And exactly equivalent is in 2017 IBM coming up with a 7-qubit device. So the parallels are there. The hardware side is researching and investing heavily. What is required is we need now the softwares that will actually work in a mixed mode, hybrid softwares, I would say, and obviously the compilers that will translate the quantum programs into quantum hardware. There are so many ways to learn. I'll not, because of the time limitations, I'll not get too much detail into it. But one is of course Qiskit and IBM. Qiskit is an open source simulator or SDK. You can actually simulate it or run on an actual computer in IBM. They are tightly integrated. So quantum computing or IBM Q is what it is called, quantum experience, and Qiskit. AWS Bracket uses Ion Q, Rigetti, and D-Wave. You have choices, but it is a paid service. Initially, $10,000 worth of time is given free, but being a new technology, you will consume that in no matter what very quickly. I would rather prefer a totally open source Qiskit and totally free IBM experience. Although sometimes you have to batch schedule your run and then wait for at least half an hour or 1 hour, or actually specifically ask the computer of lesser number of qubits to run because availability is a problem. There are at least at any point of time around 3,000 or 3 lakh in Indian term, 300,000 or 3 lakh users using and putting their work on running on the quantum computing of IBM. So weight is there, but that is fine. This would be a preferred option. Microsoft Quantum is picking up like anything, especially Azure Quantum has and Q Sharp. Similar to C Sharp. Q Sharp language is very, very good for NIST technology, which is a nice intermediate scale quantum technology, which we all of us are using today. So I would recommend again, Azure is free. At least you can start free and use it for a few months. But very, very interesting case studies and applications we'll see. Google Quantum AI, again, another equivalent to Qiskit and IBM. A combination is Google's own quantum computing with Circ as a replacement of Qiskit. They are almost similar because both are Python-based libraries, and you can go and learn from Google Quantum AI. Just even if you Google it and just search it for it, you will find all those things. Quark was a drag and drop quantum circuit built. Nobody's nowadays using it. Was an open source because the ability to design the circuit is already available in Circ and Qiskit. Nobody's working on Quark. But it was once upon a time very popular circuit simulator, quantum circuit simulator. And commercial quantum computing, D-Waves, Honeywell, Rigetti, these are the big names in commercially available quantum hardware. Very, very quick introduction. Qiskit is basically like Python. It is again a library. It has various stacks. I have purposely removed the earlier image here because that was basically you start with the Aqua, which is algorithm for quantum computing application. Terra layer, which is foundation on which entire Qiskit is built. Air is very high performance simulator with realistic noise introduced as well. Ignis was what we call the noise characterization, error correction, and some experimentation used to happen on Ignis layer. And then there was a layer called Qiskit IBMQ provider, which was basically accessing the quantum devices or accessing the quantum simulator. So this was the layer till April 2021, and IBM, which is a chief sponsor for the Qiskit. Qiskit is again an open source phenomenon, open source technology. So apart from IBM, a lot of community has helped them, and they have redesigned the whole Qiskit as a toolkit under a focus called frictionless programming. As I mentioned in my earlier slide, if you can look at it, this is what we are trying to get into. I should not be bothered about whether the computer is a hybrid between classical and quantum. I should be able to program it as if like calling certain libraries and executing those on the quantum computing, rest of the results on my classic computer, and it should be as frictionless and as seamless as possible. So what they did, they introduced a pulse level controls. So you can actually now control each qubit. You can experiment those. They introduced a new model called optimization, which we will go through it. They rearrange Terra, Air, Ignis, and Aqua. No more application Aqua is there. So those are all deprecated. And now they call it Qiskit application. And within application, there are libraries to start ahead on either Qiskit nature, which is basically natural simulation or nature related problems, finance, optimization, and machine learning, which is basically integration with PyTorch, right? So Qiskit application is your starter kit. If you, for example, I want to delve deeper into nature related use case or finance related use case or chemistry related use case, I will choose a specific application which is relevant to that domain, so that I can start, instead of starting every time reinventing the wheel and starting from zero, I can start at 10%, 20%, 30% already being built there. So I get that initial boost, right? So Qiskit application is what is going to be your single source of that. Ignis will eventually become Qiskit experiments. As I mentioned, they are changing the entire layer. So it is more like doing some uh, error corrections, finding out whether it is impacting really helping the overall results or not. Again, in quantum computing, it is never 0 or 1. It is, as I mentioned, it is most of the time probabilistic results. What is most likely result, that is what we go by. So purists will not like that, because that is what happened with Einstein, right? Because science works in certain way and the nature works in a different way. Quantum developer certification has started. You can take the advantage of it, and there is a clear-cut roadmap by IBM how they want to do the quantum-based road development. So if there are students, upcoming graduates, this is the right time and right place to get into a quantum technology, because that's what is going to be classic. Computing, classic programming is already commoditized, unless you are working on a niche area like machine learning, AI, and analytics. Rest of the programming, let's take Java programmer or C programmer or C++ programmer. They are dime a dozen. They are very available. But people with a strong mathematical background and quantum computing experience will be high in demand in another 2 to 3 years. Similarly, like what we did for Qiskit, equivalent same thing is available in Circ, which is a Google Quantum AI. You can build circuits, you can simulate the devices, you can do the end-to-end experiments, run them on Google's computing, such as quantum approximate optimization algorithm can be run. So you will again see here that using your laptop or your computer, you can actually access Bristol Cone or Foxtel from Google or IBM's computers through Qiskit and run your programs once. But essentially what happens is, when you are doing trial run, we prefer to do some simulation, get the result. Once we are ready with that simulation and we are aware that program is not going to misbehave, then only we put that batch to run on the actual hardware. TensorFlow Quantum is the very upcoming technology. After Azure Quantum, TensorFlow Quantum from Google is the second one, which is very, very upcoming and promising technology. It is a Python framework for quantum machine learning, and that's how latest it can get. So Google TensorFlow expertise, along with the quantum computers or hardware they are combining it together and creating a very, very interesting combination there. Market mapping. There will be service providers like IBM, Google, Microsoft, Rigetti, D-Wave, end-to-end provider. They have everything that is required. There will be hardware system builders, like specifically only building the hardware, giving it to the full-fledged or end-to-end service provider. Alibaba, for example, has its own hardware. IBM, D-Wave, we have seen Google has its own hardware. Circuitry, like quantum circuitry build-up companies like QCI. Software services, you will see around 30-40 startups start doing wonderfully well. Last 1 year that has come up. Two of them are, I will really like you to at least understand how they started and what they are doing. One is Zapata Computing. Really fundamentally they are doing some amazing work, and there is 1QBit is another one, QCware, and 1QBit is another one promising one, and Zapata. They just check their Zapata quantum computing or 1QBit and see the work they are doing, what is happening. Then you will realize it is no longer a research topic now. It is basically people are now starting to apply these learnings into their day-to-day use cases. And then there are research labs that will continue to be. So whether it is a Microsoft sponsored Sydney University, Purdue's lab, or MIT, Caltech, Chinese Academy sponsored by Alibaba, Academy of Science in China. So these are the research labs. So you can, marketplace are 4 types. End-to-end solution provider, they have everything. IBM has Qiskit, hardware as well as everything. Google same thing, Microsoft same thing, Rigetti. Then the hardware, only the hardware builder like D-Wave and Rigetti. Software services, companies like Accenture have started thinking about starting a service, like what they have started a practice on AI ML. They are starting a practice on quantum computing as well. And interesting thing is, you cannot create a quantum computing engineer like you will create, or you will make them ready, industry ready in 1 year or 2 year or 3 year. It takes time. The way we are taught by Boolean logic, binaries, is different than what possibilities of quantum computing are. So it takes time. It takes a lot of switching off and switching on. Whenever I am, for example, reading about quantum computing, I have to switch off all my understanding in the binary world, and I have to give that shades, probability, everything comes together. So that's the reason why I would prefer a lot of youngster, lot of first year, second year student to start at least thinking in this direction, so that the relevant foundations are made ready. Then the another way to map the market by tactics is like this, which are the full player in encryption, hardware, software, AI. Xanadu is another promising startup. As I mentioned, be careful, keep an eye on Zapata and 1QBit and QCA. These are the promising companies of future. Ecosystem, we already discussed about it. Just make sure that the end-to-end providers will be between pure play consulting and service providers like Zapata and 1QBit, and IBM Sears, and IBM will be this side also, which is a pure play software, right? So that's why they are intersecting. If any companies, any interesting company you see, Atos, for example, they have their own hardware. I was even not aware that the Atos has invested so much. So the basic is, there is an ecosystem, there is an investment, and it's basically how do we, what is our strategy? How do we want to play this business, right? And the real presentations is starting now. I may have to go little bit over the time. I hope it is okay, More sir.
Yes, please continue.
Okay, I'll need 10 minutes beyond my stipulated time.
Yes,
So
yes.
there are few strategies. One is watch for the latest development. In general, whenever new things come, just as a business, I will keep my eye on the new things, new development. I'll first of all, because it is a quantum computing, and the realization of breaking of RSA-based encryption is very, very near future. We are not talking about a decade. We are talking about 1 year or 2 years. And nobody is going to tell you that they have broken down the RSA encryption algorithm successfully and they are successful at it. If China does it, or it's a matter of whether USA does it first. But nobody is going to tell you. And if that is the case, as a business, I will be, especially if I am in finance business, I am in an industry where I have to keep the data of last 15 years, 20 years together. I will secure my data. Be it a post-quantum ready algorithms, or making the algorithm as strong as possible and encryption as strong as possible. Creating the copies, that would be my second step. And I may be into, let's say, a transistor business, which may not have the future, or some classical computing business. So there will be some impacts. For example, the role of a financial advisor or a finance portfolio optimization, that role itself may be taken up by the quantum computer, because they do the portfolio optimization or financial portfolio optimization better than the human being. And there are some simulation promising studies on it, right? So if that happens, I'll rather be prepared to change my business and be flexible. To every wave, there are four things, or the what we call determinants, that we can see. One is just the observers, basically monitor quantum computing ecosystem, analyze what is the business potential, let somebody take the lead, we will follow laggards, basically. Let somebody burn the money. This is as as a as a organization, this can be one of the playbook or strategy, that okay, let some people spend a lot of money and then I will catch up. Only problem with that approach is, if these people have gone too far, there is no second position. The person who cracks the RSA encryption, or the organization or the nation or the country which is able to access some of the sensitive data from each other, they are not going to come and openly tell that. And what will happen is, there is no catch up game. By the time it's the learning curve is too deep, too long, and it's not possible to catch up with the observers. Say then I may actually say, okay, let me follow basically some leaders which are already there. The third strategy would be, I'll ride the wave. I will be part of the chain. And obviously then there are racing team or racing organization which are already step ahead than rest of the world. There are, if as you will see, there are in each domain there are 4 or 5 companies which are actively involved in the quantum computing research and reaping the benefits of it as we go along. So as an organization, what should you do? As a business, what you should do? You select few champions. You select, for example, in your college, you will select 1 or 2 people, not more than that, and ask them to start reading on quantum computing, so that in their final year project may be something which is related to this particular fascinated technology, or third year internship can be there. Identify the use case. This is one thing I want to emphasize in throughout this lecture is, the hardware is there, software may not be there, but it is also upcoming. It is up to us now. How do I identify the use case? How do I identify the problems that are not possible or intractable on classical computing? And once I identify that use case, rest of the things are all simple. I'm telling you, the most important and critical part is identify that business use case or the domain where you can actually implement the quantum computing, where you think. Then we will get deeper into it. We will run some proof of concept, some experiment. That is as a third step, just to prove that, okay, I'm not thinking too different here. Nobody in the world has ever solved this problem. So this is definitely a candidate and it can be solved. I will simulate it. I'll do the proof of concept in step 3. Then I will define my, okay, once it is everything is proven, I will become a quantum ready. I am still not into quantum supremacy stage. I don't want to be, because that is basically just a, what you can say, a tick mark. Yes, we are able to solve a problem in which will take 300 years in 3 seconds. That is fine. From business perspective, once I know that my experiment was correct, my proof of concept was right, proof of technology is right, which means that my use case, the problem statement is correct, then I will plan my course. I need to go become quantum ready, and then like I will also be open to new changes that are happening, because it's a ever changing world. Last year what I talked about Qiskit, today I cannot talk because it has changed. In last November, December, they have changed the entire organization of how the Qiskit will work. So be flexible, adopt that change, and most important is achieve the quantum advantage. We are not talking about the quantum supremacy. 3 areas which will impact mostly: machine learning, because it is now possible to sample more data, have a better deep learning algorithm. Each other, they complement each other. From machine learning, you can understand better behavior of quantum computers, and the other way around also. Simulation in chemistry, pharmaceutical materials, and optimization. Traveling, transportation, how to find out the shortest, quickest, and the less time consuming path from the network of traffic, how to get rid of everyday traffic congestion. And people have implemented it. Air traffic controls, for example, financial services. So you will see that the impact is, there is a family of algorithms called chemical simulation applied in the molecular design. Engineer a chemical or material for a given purpose. I want a degradable plastic, for example. Today, in classic computer, it is not possible to even simulate or even uh, uh, design a complete molecule on the computer. The reason being, we are still able to survive. The reason being, we take a lot of approximation. We convert, as I mentioned, convert that exponential problem into a, put some constraint, certain assumption that may not be right or wrong. That's why it takes 10 years and 12 years just to make sure that we have the chemical compound or the pills that we are taking do not cause any side effect, because it's all approximation. It's not an exact simulation. So that is where this will be very, very useful, because now I have enormous states to apply for, and that is, I'm not constrained by either 0 or 1. I don't want to take the, I can be in any state in between, right? And scenario simulation, imitating representation of something, study, risk management, fraud detections, pricing, how the markets will behave, all those scenarios. What the classical case would be, if I am an insurance company, what I can simulate the behavior, what will happen, what kind of natural disasters are going to come based on the past enormous set of data, because that is what the processing power tells me, right? Optimization, this, every other problem will have optimization, whether it is a routing, networking, energy distribution, your portfolio rationalization in finance, everything. And then the AI, of course, it actually does a very good job in terms of being a data classifier and predicting certain patterns out of by the quantum computer rather than the classical AI. So AI is the another field where it's expected to cause the maximum adoption and impact. Some of the algorithms that are going to be very, very useful, Grover's algorithm, you need to watch for them. Your variational quantum eigen solver, your quantum approximation optimization algorithm, these are the workhorses. These will continue to uh, fine tune and enhance. And then there are algorithms like HHL, SP. SP is an interesting area, which is basically a type of programming which will suit the quantum computing, rather than it's a semi-definite programming rather than a definite, semi-definite programming. How to deal with possibly probability, percentage. I think I'm 70% correct. That kind of philosophical thinking will start, right? And Shor's algorithm. So these are the purebreds. They will continue to be the algorithm of choice, algorithm of interest for the community. As we mentioned, today we are here. We are talking about taking advantage our capabilities. You can see that we are just being quantum ready. We are not yet in the quantum advantage. As time passes, maybe in next 1 or 2 years, we will cross this curve and start getting into exploring more and more benefits, whether it is then quantum computing in the area, or quantum communication, or quantum sensing. Quantum sensors is already in market and being used. It's a area on its own. As I mentioned, nano sensors, quantum sensors is is being used in a lot of accurately measure whether it is sensing a submarine below the water, sea water or seabed, or whether it is putting a quantum sensor on the logistic or the freight terminals. It's already in use and it's being captured. It's very, very useful. So this area is already being exploited by the companies. Quantum communication is a lot of research going on. How can we use entanglement and your uh, code density or code condensation for communication? And obviously we are discussing today on quantum computing and algorithms. We'll see what are those areas, how they go. Across the industry, optimization will always be there, whether it is supply chain optimization, route optimization, or anything else. Data science, mathematical modeling, and then quantum chemistry. How do I reduce the data center energy consumption, for example, or how can I design if more efficient batteries? We'll go through some of the case studies and find it out as well. Then consumer goods, natural resources, financial services, government, healthcare, technology, network optimization, semiconductor chip layout. What is the best? Fault analysis, fault tolerant computing. Even the classical computers will benefit from this phenomenon. So first use case is finance. Especially in finance, you will find portfolio optimization. That is my holdings versus what are the various assets that I can invest in. Pricing, risk analysis, fraud detection, I already mentioned, market prediction. These are all possible by using quantum computer, and some of the names I will discuss, they are already doing it. So again, it is whatever information available publicly is, we still don't know what is the latest status of their research and their foray into this field, right? So JP Morgan Chase is they have set up a future lab for applied research and engineering called FLAIR in collaboration with IBM. They are already experimenting with quantum computing in the areas like how do I identify the better trading strategies. So now you can understand the traders will have a tough time. Portfolio optimization, asset pricing, so many various investment and assets to invest in, so many permutation and combination in how to get maximum return on investment to my clients. That is what the trading strategies will decide, right? So they are already using it, they are experimenting with it. The stakes are high, as you can guess, because whichever bank is able to find this out, they are going to, it is going to benefit their customer and the institution, financial institution. It's not the technology that is going to be, they are going to put it in the open source and say, okay, this is the algorithm, quantum computing algorithm that we are using to define our trading strategies. Nobody is going to do that. It's a end. At the end of the day, it is a business, and that's why there are very closely held secrets and tie-ups that are happening in business. Barclays and IBM, same thing, but the Barclays is using it for the settlement of batches. The batch based settlement they are using. They have already started to optimize that settlement of batches and implementing the algorithms to take benefit of quantum computing. Interesting is NatWest Bank and Fujitsu. So they have already implemented quantum inspired. It is not a fully quantum, but a digital annular, what they call Fujitsu, and they are able to get the speed up to 300 times than the traditional computer, along with the accuracy as well. So what they are using, they are optimally balancing the portfolios, asset classes across the asset classes, and so many thousands of options that are available to the investor. So NatWest Bank UK and Fujitsu, you can't call it a pure quantum computer, but what they call Fujitsu called is a digital annular, but it's a quantum, pseudo quantum, you can say, computing. And they already achieved it. There is a case study available if you look into the internet, and there are some references I have given also. Quantum algorithm theorized by QC Ware, and Goldman Sachs is able to speed up the Monte Carlo simulation, which is the only way that we kind of take care of a lot of financial market fluctuations and changes using Monte Carlo simulation. But quantum aware Monte Carlo simulation are much more accurate, as well as can be done in a really fast manner. So these are the few in finance, especially in banking and trading. Insurance Alliance, RBS and Alliance has started their own computing startup, 1qubit. They have put in a lot of money into funding it. They are using it for especially for the risk modeling, automation of claims function in a real time over the smart devices. Again, quantum sensors are coming in picture. Again, it's not something which is we are living in a dream. These are the companies, they have started using it also. As I mentioned here, already 300 times speed up is over the traditional computer is using digital annular is achieved by NatWest Bank. Energy transportation, ExxonMobil Mobile is basically they are using it for a variety of application, how to optimize country's power grid, for example, how to perform productive environmental modeling and accurately measure the requirements in each area of energy requirement, chemistry calculations to enable discovery of new material which are more efficient, and how to reduce the carbon footprint, for example. That's some of the uses they are doing. Traffic optimization using D-Wave by Volkswagen, it's already done. Go to the Volkswagen or search for the D-Wave and Volkswagen, how they have reduced the traffic by how much percent, up to 30% of the traffic congestion has been reduced by using quantum technology. Production line optimization by BMW using D-Wave's computer. BMW, Volkswagen, and 10 others, total European company, they founded a setup called QTAC, Quantum Technology and Application Consortium, in June 2021, just to make sure that they are not left behind, right? So energy and transportation sector is also actively using. Very interesting use case in case of Mercedes-Benz. They are using it to design better batteries, and we'll quickly go through it, what exactly is happening there. Ford is using NASA's quantum laboratory for the autonomous car research, and they are also working with Microsoft for reduce the traffic congestion and reduce the travel time. So various routing recommendation. You can see the businesses optimization is a one use case where if there is a optimization required and classic computing cannot do it, how can I, whether it is a network optimization or route optimization, how can I implement those concepts and design my own algorithm? That is the best place today's world for any of you. So as I mentioned, use case identification is, or problem statement is the most important thing that you can take away from this session, saying that I need to identify a problem, then the solutions are in place. If it is not there, the community is so closely correlated and they help each other so many times. Even if you reach a big scientist in IBM Quantum and ask him a simple question, how does he will answer. That is how active we as a community in quantum computing are. Aerospace. More, sir?
Yes, sir.
Sir,
Yeah.
sir, actually session time is over. Still, we can wind up within. Can we wind up within 2 minutes?
Yeah, I will try to.
Yes, sir. Yes, sir.
Okay. Aerospace material. The interesting one would be, apart from the NASA, OTI Lumionics is something which is very important. This use case, I am going to share this. Please go through it. they are coming up with a new material for screen design for my mobile phones, OLED. They are already designed the material. Cyber security, AI, ML, these are the companies from Accenture, Microsoft, Google. Everybody is working on how do I enhance my classical machine learning and AI using these. Chemicals and healthcare. Uh, Interesting would be Microsoft Quantum with a Case Western Reserve University. You can see this one is the left one is MRI scan done by the quantum computer, and right one is the classic computer. The graphics quality is similar. What is important is this was generated 3 times faster using the quantum algorithm to scan the MRI and interpret it. Very quickly, I will tell you how to go through this algorithm, your quantum computing use cases. If you click on that link, you will see that I am trying to get into IBM Quantum Lab, and I can see the various files, one of which is the servers were unavailable because I was not using it. So they have requested it now. Good. So this is where you would actually, if you go to the Qiskit, use the version on the cloud, uh, uh, and then you go to optimization and take any program, any optimization program, and try to find out, run this program, read through it, and then try to run it here itself. For example, I'll just show you how to do that. If I select here and run, so likewise I will go through all the code snippet, run it here, and understand what is happening. This is being executed directly on the Qiskit cloud. Okay, so this is important. I wanted to share this with you for a reason, because you can actually do that optimization example directly on Qiskit, and the write up here on Medium is basically will tell you what you need to be have in place. What is going to happen 22 and beyond? Quantum AI is a new field. Quantum biology. You can see that Dr. Rainer Dumke and team has put a micro animal called tardigrade at minus 273 degrees centigrade. That is absolute zero. They are kind of immortal animal. They start cryptobiosis, and then they were able to show that there was an entanglement, quantum entanglement between two species. And read this interesting what will happen in biologies, quantum biology, better quantum system. We are going towards a quantum advantage first, then the supremacy. Lot of philosophical discussion. The world is not black and white. World is not 0 and 1. The lot of discrete step in between, right? Skills shortage will be big question. So if you want to create a next generation of quantum engineers, quantum computing professionals, you
Bhatkar sir,
should.
Bhatkar sir, we have to start next session at 12. Will you please?
I am closing it.
Yes, sir. Yes, sir. Yes, sir.
Skill shortage, consolidation will happen. Either China will lead or China will fade away, because there was a quantum lab leak on 26 November. So, however the claims may be, whether they have achieved supremacy or not, lot of profit pressures would be there, because lot of money has been put up into the industry by the investors. These are the books. The two things: subscribe to Harvard Business, Fortune, the EPJ Quantum Technology Springer Open magazine. Listen to Kiskit channel on YouTube or on Medium, and one of the book by my good friend Dancing with Quantum Qubits is something which Robert or Bob Suter has designed. So go and read it is if it is available. This is one of the best book on quantum computing. I thank everyone, including Dr. Kharat sir and my colleague and friend Dr. Heman Goswami, apart from my family. And most important thing is nature isn't classical. It's not 0 and 1. And if you want to make a simulation of nature, you better do it on a quantum computer. That is what Richard Feynman desired for, and I think we are towards realizing that dream. My mail ID is here. You can start this thing. Thank you for your time. Thank you for your interest. Sorry that we had to extend little bit beyond, but we started also late. So
Yes, sir.
thank you very much.
Thank you,
sir.
sir. I'd like to thank sir on behalf of Computer Engineering Department, MET's IOE. Sir covered various topics like prerequisite of quantum computing, then business strategies and applications, also case studies and practical from where we can learn. Also, sir have given many options from where we can start learning quantum computing. Definitely, it will be beneficial for new learners. So, thank you, sir. Thank you very much.
My pleasure, and thanks for giving me this opportunity. Thanks a lot.
Thank you.
Thank you very much, sir, for your session. Any question from participant side? Kharat sir, do you want to say something? Sir, you muted. Unmute, please.
Am I audible?
Yes, sir. Yes, sir. Now audible.
Okay. As time is running fast, we can discuss in person with Bhatkar sir about the various options that are available in the market towards the quantum computing hardware and the practicability of those for the existing practical setups or the changes needed in the algorithms for their implementation with the open source technologies. We will discuss all this. But as the time is running, we don't want to kill the time of participants. They need to have the break of minimum 5 to 10 minutes, which we have curtailed from half an hour. So please continue with the sessions. I am very much thankful to Bhatkar sir for his kind acceptance and good quality content sharing with all of us. Thank you, sir.
Thank you for providing this opportunity. And there is a good question, Dr. Ajit Kumar Shukla. You can contact me directly. How can educational institute collaborate with the industry? This is precisely what I am also looking forward to. There is a small startup that we have started on quantum computing, and we definitely like to explore this idea. As I said, a lot of money, but a lot of pressure is there from the business to show the result. So we'll definitely do that, and if required, we can. I will be sharing entire material, and if required, we can have one more follow-up session as well. Not a problem. Thank you very much, guys. Thank you.
Thank you, sir. Participants, now session is over. You can take a little break of 10 minutes and rejoin at 12, possibly at 12. Thank you.